Hi everyone, and welcome to the IFST webinar AI in Action, organised by the Innovation Special Interest Group for Packaging and Product with IFST. My name is Sheila, and I'm an NPD manager within the beverage industry and the events coordinator with the Innovation Special Interest Group with IFST. AI is moving really fast across multiple industries and applications, and this webinar's objective is to explore the use of AI specifically in innovation. The webinar is being recorded and will be uploaded to IFST's Webinar Hub. Feel free to make comments and ask questions throughout the webinar using the Q&A button at the bottom of your screen. You can also upvote other people's questions by clicking the like button next to their question. There will be a Q&A session after the presentation where we will respond to as many of these questions as possible. The speakers today are Anna-Sophie, who is the founder of Nibblr, which is an AI-powered platform transforming how food and beverage companies reformulate and innovate. And she will be taking us through an introduction to the platform and how it's used. And then you'll hear from Tom Hollands, who is a director of Alyn and the innovations and technical director at Rainer Foods. And he will be taking us through some case studies of how he has applied AI in industrial applications. For more information on our speaker's biography, please look at the IFST website. And with that, I will hand over to Anna. Thanks.
Good afternoon, everyone. It's really great to meet everyone here, and thank you so much for IFST for inviting me. I'm Anna-Sophie, founder of Nibblr, and I'd love to share how AI today is beginning to transform food product development specifically, not necessarily as a futuristic idea, but as something that's already reshaping how food is created, and especially I'll focus on in the next 10 minutes through the lens of how we're building Nibblr. Nibblr is a platform designed to help food and drink teams reformulate, develop new products, innovate much faster, smarter, and with more confidence, especially with the support of AI. And it's not about robots making recipes. It's very much about giving people that already are creating these recipes and products more clarity and more control to go through that process. So to get started, like many of you, I've actually experienced firsthand as a founder of an alternative coffee business how fragmented and slow product development can be. Over the last few months building Nibblr, I've then immersed myself much wider in the food ecosystem up and downstream. And I've spoken to food founders, chefs, NPD and R&D managers, manufacturers and ingredient suppliers. And what's been really interesting that nearly all say the same thing around food development. Specifically also food innovation today takes too long, costs too much, and is still built on quite scattered data and processes. Everywhere from ingredient specs to regulatory checks, the majority of the industry still depends on manual spreadsheets and quite endless version control. So NPD and especially reformulation has become increasingly complex, which I'm sure many of you know, driven by the increasing regulations, the compliance, health and sustainability targets, the volatile cost pressures from raw ingredients, and then the consumer expectations. But the tools to support that process haven't really evolved as much. So across the industry, we've seen companies take anywhere between 6 to 18 months to reformulate, and still the majority of products fail because it seems to be a nightmare to hitting that right nutrition, cost, and quality trade-off while navigating systems that are still quite outdated. So while there's incredible expertise within R&D and NPD teams, much of the process is still defined by kind of iteration, trial and error rather than intelligence. So really, food companies are navigating this perfect storm about observing health regulations and nutrient profiling targets in the UK, rising supply chain volatility, raw material cost, and growing demand for consumer transparency and sustainability. And teams are under increasing pressure to deliver healthier and more affordable, but also great tasting products, but with limited tools, limited data, and limited time. And that's where we really see where AI can start to really change things, not by replacing people, but very much by amplifying what people are already doing. So when we talk about AI in food, as I said, it's not about robots cooking or replacing chefs. It's about giving food developers more clarity and control. And we've seen that AI can really help in three key ways. One is around data structuring, so bringing together nutrition, cost, and functional data of ingredients from many, many different sources. The second one then is around insight and pattern recognition. So AI can help us identify ingredient substitutions, new formulations, their impact that we might just not see or have experience with. And then that scenario testing and around actions. So being able to running what if reformulations to understand how changes in ingredients affect the wider product nutrition profile, flavor, quality, and compliance before even entering the kitchen or the lab. So in short, the goal isn't so much about automating decisions, but to help teams make better informed decisions faster, with more confidence and fewer costly iterations. Across the food industry, we are already starting to see AI move from research labs all the way to real kitchens and manufacturers, and a few consistent lessons are emerging across those. First of all, AI is already transforming ingredient understanding. So I attended the Agri-Food Innovation Summit in Singapore last week, actually, where I had the opportunity to listen to a number of leading scientists and R&D leaders who spoke about how AI is now being used to link ingredient structure to functionality and sensory outcomes. They are creating models where teams are now able to predict how, for example, proteins interact, how structure links to texture, how certain plant compounds drive sensory outcomes before trials even begin in the lab or in the kitchen. Secondly, AI is already driving and is a very powerful tool for product formulation and especially also flavor innovation. One of the best known examples in the industry, and some of you might have heard about a company called Notco and their end-to-end AI platform for product development, which is called Giuseppe AI. Giuseppe AI essentially analyzes thousands of plant-based ingredients to recreate the flavor, texture, and structure of animal products, everything from milk to mayonnaise, matching that molecular composition of ingredients to sensory experience and outcomes. And thirdly, and what's consistent across those two examples from lab innovation all the way to market discovery and innovation at Notco, is that AI only works when it's grounded in really strong data and scientific context. So AI doesn't just replace food science, but it very much accelerates it. And it's a really powerful enabler that helps teams move faster through the process, make better informed decisions, and be able to bring healthier, sustainable, and commercially viable products to market at scale and much faster. What we've been doing at Nibblr sits very much one layer downstream of all that research. So we are on a mission to translate the science and the ingredient intelligence into practical, everyday decision-making tools for food teams applying AI. So our goal is to make the insights that drive innovation at companies like Notco, for example, accessible to everyday food teams, not in a lab, but in their day-to-day work. So the platform brings together ingredient intelligence from nutrition to functionality, to claims and cost all in one workspace. And teams can now build or rethink recipes in minutes, instantly see how ingredient changes affect the wider product's nutritional profile, its claims, the quality of the product, everything from sensory to thermal processing to functionality, and also model reformulations of recipes against their own company's health and commercial goals. And then very much explore ingredient swaps with clear reasoning. So to give you an example, for instance, a brand reformulating a sauce and looking to remove seed oils from their products might be able to use Nibblr by reducing the seed oils, exploring vegetable-based alternatives, and instantly see in the recipe simulation how those swaps affect nutrition, flavor, and cost. So what used to take, I guess, weeks, months, and days can now be explored in minutes. And as we build Nibblr, we understand that the quality of the data is absolutely critical. So this principle of trash in, trash out is especially true in food formulation. Hence, our approach combines human expertise and machine intelligence. We build our product by building and training models using verified scientific data, and we validate each insight with food scientists, chefs, and regulatory experts. And in that way, the system doesn't just start predicting ingredient swaps, for example, and recipe formulations, but it really also explains and gives the broader context. And we really believe that this balance is key for trust from food teams, and as well adoption across the industry. And ultimately, that balance between human and data insights is what makes AI a really true enabler of being able to create healthier, sustainable, and more resilient food products. When we started, we're still very much in the early stages with the development of Nibblr, but when we started testing our early versions with development teams across the food ecosystem, so both from high growth challenger brands in the UK all the way to NPD teams from large leading manufacturers, a few things became very clear. First of all, I'm sure many of you are very aware, real product development is messy. Teams rarely work on one recipe and a single recipe. They're developing components like doughs and fillings, sauces, and they all need to come together in composite products. Secondly, everything changes all the time. I think this is increasingly so. Ingredient costs change, suppliers change, regulations are changing. So nothing stays fixed. So teams really need an ecosystem with flexible living data rather than just static spreadsheets, what the industry uses at the moment. And thirdly, time is probably the biggest constraint. So everyone we've talked to really manages anywhere from 10 to 100 recipes at once. So if a tool slows them down, it probably won't get used. But on the other hand, anything that speeds up the iteration through those recipes, through those product innovations, that anything that helps model nutrition, NPM scores, claims, flavor outcomes, is immediately valuable as it reduces the human and time capacity on there. Working with the various different NPD teams, we've also seen that, especially with large organizations, they need a system that helps them think and test much faster. And we've had feedback that Nibblr essentially, or tools like Nibblr, are ideal or an ideal place for early stage exploration of recipes and quick trial and error before then that deep development in the kitchen or with manufacturer. And especially that ingredient swap feature is extremely helpful because it helps model recipes in minutes rather than days and weeks, and relying on loads of kitchen trials and spreadsheets and manual input. So where we see the biggest value in a tool like Nibblr is very much the visualization of trade-offs between cost, again, quality, function of a product, and compliance in one place, in minutes rather than days and weeks. Through these collaborations, we've learned what AI for food really needs to look like. So first of all, as I said, trash in, trash out, the quality and the structure of the data is extremely key, and that quality and data needs to evolve. Then trust is built very much through transparency. So we've seen that food developers don't just want to see why, well, they want to see why a swap is suggested, not just that it is suggested. So when someone gets an ingredient swap suggestions, they need clear reasoning that they can stand behind that when the product then also reaches the kitchen, the factory, and then the retailer. Second, the speed matters, but speed without the wider context is just noise. So the real power of AI lies in helping teams make confident trade-offs, understanding, for example, how an ingredient change affects a product's NPM score at the same as its fiber claims as at the same time as functionality, for example. We tested Nibblr with a quite fast-growing challenger brand that's constantly expanding its SKU range. And the founder told us that using Nibblr as a platform They loved that because they could calculate nutrition claims and NPM scores instantly for various different recipes, something that used to take them days per product, sifting through various different online guidance and resources. So again, for teams with limited capacity, just being able to see compliant thresholds immediately and understanding why a claim qualifies or doesn't is generally a breakthrough. Third, the adoption really depends on respecting real workflows as well. So we mean by that protecting obviously ingredient, recipe IP, integrating with existing systems and fitting naturally into how food teams actually work is really, really key. And then finally, AI must also learn from people and what they are creating, not just give information and inform them. So every reformulation, every new product development should make the next one faster and smarter. And in large teams, that often means, and we've seen that, is really capturing the outcome of the kitchen trials based off the work that they've done in Nibblr and feeding it back into the system so learnings can potentially travel across teams, departments, and product categories. So, for example, a developer who's been working on reformulating a product in the sauces category, they discovered an interesting swap through Nibblr, have done it in the kitchen, and discovered that it can actually improve both the sweetness and the fiber content, but it would be really interesting to feed that back into the system so that other people from other departments and teams can plug into those learnings and potentially reformulate across other categories. So the human feedback loop doesn't just refine individual recipes, but it really strengthens our formulation engine, making the suggestions much more contextual, much more relevant over time, and ultimately much more trustworthy. And that's really how we are building Nibblr as a platform as well. So it's not just another dashboard that's kind of static and just sits there, but it's really a living system that evolves with every recipe, with every ingredient and insight that teams provide it as well. So to wrap up, I'd say if there is one takeaway from this session and what we've been going through in the development of Nibblr is that AI in food innovation we don't see it as a replacing people, but it's really about enabling them, and especially by connecting big data, surfacing insights, guiding smarter action, we can now cut through the complexity and the maze that food development can be at times and build better products, whether that's healthier, more sustainable, or more commercially viable products faster. So I believe that the future of food innovation will especially be driven by those who integrate and use AI and combine the human and machine intelligence and augment the human's creativity. And that's what we're really building at Nibblr. It's not just automation, but very much augmentation for faster and smarter innovation. Thanks so much for listening. I hope this was interesting. And my hope also is really that tools like Nibblr spark more collaboration between different stakeholders. So I'm really keen to connect with anyone after the session as well who's interested to chat and exchange opinions. And I'm going to hand over to Tom now.
Thank you very much. I'm going to do the special screen sharing now. Okay. Thank you for that presentation. It's very interesting. And we're going to dovetail now into that. Rather than looking at the development side at the top, I'm going to present to you on actual AI deployment within a food manufacturing setting. My name's Tom Hollands. I'm the Innovation Technical Director at Rainer Foods. I'm also one of the directors at Alyn, and Alyn is a joint venture that we have produced with software imaging off the back of the S3 project to exploit the technology we developed as part of the S3 project. If you're interested about the S3 project, then you can Google it or s3project.net and you can find out some more about that. So, where are we? Firstly, I'm going to set the scene. Food industry, recalls and withdrawals. As I'm sure many of you are familiar with on this call, these are both costly things that happen for a business. not only in terms of your wallet, but also for the environment. There's been some very eye-watering costs battered around that, nationwide recalls can cost in the region of over £1 million. And that includes all the costs of pulling that stock off back, paying fines, times to investigate, root cause analysis, and everything. Very expensive. And not only expensive, they most definitely damage your brand. They damage consumer trust. They are a time sink for teams as well, in terms to investigate to root cause and put in the corrective actions. And also, they damage your team morale. So in order to control this, businesses invest a significant amount of resources to mitigate that risk. However, problems still happen. So there was some work done a couple of years ago that looked at a 5-year period. I think it's led by Queen's University. And I looked at all the recalls that happened in the UK over a 5-year period. And by far and away, the most common cause was allergenic issues relating to mislabeling or incorrect packaging being used. And then another significant contribution was incorrect date coding, being another big contributor as well. And this goes to show that even with all the resources that businesses, FBOs, food manufacturers deploy, problems still happen. And let's be honest, a lot of those controls are still require human operators to visually verify that this is the correct pack and I'm making this product and it goes into this pack. And even BRC has particular sections dedicated to creating to this risk, insisting on certain procedures and handovers and packaging not being near the production line, etc., etc. So as part of the S3 project, we looked at this, and it's a significant cost, and it also had quite a significant environmental toll as well. And so the team worked and produced something that we've called Sentinel. And what Sentinel is, and we'll go into some of the detail later on, it's a system that effectively allows you to check every single pack that goes through your production line, and it reads that pack and it can detect incorrect packaging being used through a system of inference, and also incorrect durability dates as well. And when that problem is identified, the line stops and it sends a very simple push notification. This is what the problem was. So this is quite a straightforward application. Before we started this project, we do have other AI use cases, and I will touch upon one of them towards the end of this presentation. But previous experience with AI had required significant data sets to train the AI. I remember we had a project quite a few years ago when we were looking at tomatoes, and having to have a library of 20,000 images to try and train an AI to detect a slice of tomato was quite an eye-watering resource. However, things has rapidly changed now. So much, in fact, that is almost a twist and go solution for some niche applications. So let's just go into the detail of Sentinel a little bit further. What is it? Well, it's actually quite a simple setup. What it requires is a camera there, quite a high resolution camera. It requires a small server, a Linux style server. It requires some cabling and whatnot. It requires fixing to the end of the conveyor belt. You can have it standing, as you can see, like that, or you can have it in protected housing boxes, and there's other ways and means that you can deploy this solution on your line. And then you also need some products to train it against. But it's actually quite a simple setup. You don't need a great deal of area to deploy. It's quite useful for legacy equipment. It's definitely been hygienic designed. Really game-changing thing about this AI is actually it's very easy to train. I need a sample size of around 30 to train the AI on the new piece of packaging. So you can very easily train new packaging, and you can also amend existing packaging as well. And the brilliant thing about this, if you can physically see a problem with a product with your bare eye, so can the AI, and you can train it. So once you're taking a picture of a product, you can train it to look for other deviations as well. Another example, we've recently trained it is bread color to detect correct bread colors being used. You could also train it to detect foreign bodies. As long as it's visually, you can see it from the top, and numerous other things as well. And it is quite cost effective in terms of you can redeploy the existing human checks to other value making activities as well. And the brilliant thing about this type of deployment is the Sentinel system doesn't go for a break, doesn't go for holidays, doesn't call it sick. When you turn it on, it works. You turn it off, it stops working. And yeah, it tends to keep on going and going and going. You won't get 100%, but you'll get quite close to it as well, because it can pick up anomalies. Even a fingerprint, it could stop the line if there was a fingerprint on the front space. But you know, that is a quality defect in itself. So moving on, how do you actually set it up? Well, you get your Sentinel system, your camera in a box with lighting or so, you attach it to the line, and then you need to calibrate the triggers. And the triggers are effectively it's the time taken between the product going through and the image being taken, and it zipping off to the AI. So once you set up that, you then pass a sample pack through it, takes a picture of it. You go to your picture on the viewer and you select the areas with a box on the areas that you want to train the AI. And then you put some more sample packs in. So it starts pulling up the data set. So after you've then created that for that particular SKU, you then integrate the Sentinel system into your existing manufacturing software. And because this works for a system of inference, effectively it says, what is the manufacturing app or the ERP or the software solution? What are we saying is being made on this line? And what is the product packaging saying, the actual label? And it compares it like with like, as well as durability date and other visual differences as well. And then after you've done the integration piece, you just start running your line with the correct packaging. And you start introducing you effectively abuse check the system. You put in the wrong pack, you put in the incorrect use by date, you put a purpose quality defect on it to check whether the system works. It works, brilliant, go, produce, start running with it. That's as simple as that. How does it work? You know, what's the bit set at really, really, really high level? A photo is taken of the object, and a photo is taken of every single object as it goes through the trigger. The AI then looks for the areas it's been trained to look for deviation on, and it compares that with what the data set says it needs to look like, and it verifies it. If the product is what it should be and it's got the correct durability date and the other quality things, nothing happens. They just keep on going through. But if it spots single deviation, the line effectively stops, and a push notification goes out to the quality, goes to the quality team, and also the team leader on the line, and says this is the problem. The line stops, and it allows you to put that problem right there and then. One of the big drivers for this is a problem we encountered 2 years ago or so, when our date coding machine decided to reset to the year 1999, but we didn't spot it for a good 2-3 hours or so, because it's a very, very long run, and it created a lot of additional work, a lot of wasted time, a lot of annoyance, and a lot of stress. And even with all the systems of control that we had, there was a very, very low likelihood that would have been spotted, and to that point that quality check was carried out. This allows us to even reduce that window even further and address the problem there at that point, because that is the most efficient place to put it right. for every, you can see this, there's a linear cost when you have a problem to the point that problem originated. So it's more and more expensive to put it right the further and further you go away from that point. And also there's a strong environmental sustainability cost to that, as well as a cost to the business and financial terms as well. So this is a very, very high level use case intro into one particular use case of an AI that we've had. But I've got time for just one more short one, a little bit more fun. So at Rainer Foods, we have a real-time locational system that allows us to geographically track assets and people as they move around the facility. One of the game links that we use to help with this has an accelerometer in it, and this accelerometer can tell you how fast or what position on that you are as well. Now, in the food industry and most manufacturing sectors, slips, trips, and falls are the biggest cause of riddles. They are most common reported accident when they are reported, because actually there's a bit of an iceberg problem here. Very few of these accidents are actually reported, and yet it's one of the areas that is the biggest cause of riddles. So there's a problem here. So what we've done is we got the health and safety team. It's a picture you can see there, and we plugged in another AI, and we got our health and safety team and some other members of the team. They're just around the corner to try and slip, trip, and fall as many different ways onto that mat as possible within that room for around 2 hours or so. And then what we done is we trained the AI to look for the signal of what a slip, trip, and fall looks like. And then after we trained the AI, then we plugged that into our real-time locational system mapping or data visualization. And that allows us to create a ping, a little dot on the floor plan of where that near miss happened. And very quickly, this allows us to root cause and trend slips, trips, and falls, and identify, in one case, an area is very prone to mayonnaise ending up on the floor, which was a cause of slips, trips, and falls. Another one was a trailing lead that we had in the hygiene wash-up at a certain stage, but it allows us to geolocate and then get into that root cause really, really quickly and save the team's time to get to that problem and solve it, and also help create a safer working space for the colleagues around us as well. So that's a quick presentation talking about 2 different use cases of AI. I hope you found it interesting. If you'd like to learn more about it, or even if you want to play around with the technology yourself, then please drop me an email, or you can go to the Alyn website to find some more information about Sentinel and also the S3 project as well. Thank you very much for your time.